So my dear students, in this video I am going to explain the angle sum property of polygon. You know that angle sum property of triangle, in this sum of all the angles, for example this is a triangle ABC, so sum of all the angles in a triangle, that is 180 degree. This is called as angle sum property of triangle. In case of quadrilateral, whether it is a square, whether it is rectangle, whether it is parallelogram, whether it is kite, in all these cases, if it is a quadrilateral, the sum of all the four angles, means A plus B plus C plus D, will be 360 degree. But if I ask pentagon, what is the sum of all the angles in a pentagon? What is the sum of all the angles in hexagon? What is the sum of all the angles in heptagon, octagon, nonagon, and so on? So for that there is a formula. The formula is this. Formula is n minus 2 multiplied by 180 degree. Whatever is the number of sides, you have to subtract 2 and then you have to multiply 180 degree. But how this formula comes, I am going to explain this also. See, in case of pentagon, this is pentagon. In pentagon there are 5 vertices A, B, C, D, E, and we have to find the value of sum of all the angles A, B, C, D, E. For that you see that n is equal to 5 because there are 5 sides. So n is equal to 5, we get what? 5 minus 2 into 180 degree. 5 minus 2 means 3, we get 180 degree, 18 3 is 54, so 540 degree. So by this formula you can find whether it is pentagon, hexagon, heptagon, nonagon. If this is nonagon, you have to put n is equal to 9. So 9 minus 2 we get 7, and 7 into 180 and you get that value, sum of all the angles. But how this formula comes, I am going to explain this here. See here. Suppose this is a hexagon. Total 6 sides are there. A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. And this is pentagon. This is heptagon. 1, 2, 3, 4, 5, 6, and 7. A, B, C, D, E, F, G. And this is quadrilateral also, A, B, C, D. See here, there are 4 sides, n is equal to 4 sides here. Here n is equal to 5 sides. Here n is equal to 7 sides. Here n is equal to 6 sides. Now, how many triangles you can make? There are 2 triangles. If n is equal to 4, the number of triangles we get 2. Here n is equal to how many? 6. The number of triangle you get 1, 2, 3. Oh, sorry, 4. 1, 2, 3, 4. If pentagon, if n is equal to 5, the number of triangles you get 3. Here 1, 2, 3, 4. 1, 2, 3, 4, 5. If n is equal to 7, the number of triangles we get 5. So you see that every time you get 2 less number of triangles. N is equal to 4, the number of triangles 2 less. N is equal to 5, the number of triangles 3. N is equal to 6, the number of triangles 4. N is equal to 7, the number of triangles 5. Every time you get 2 less triangle. So you see that vertices of all the triangles, vertices of all these triangles are on the vertices of the pentagon, hexagon, heptagon, octagon, all the polygons. These vertices are not anywhere else. They are all the actually part of vertices of the polygon. Therefore, if you find sum of all the angles of this triangle, sum of all the angles of this triangle, sum of all the angles of this triangle, sum of all the angles of this triangle and this triangle, then you get sum of all the angles of the polygon. This is by n minus 2, means n minus 2 is the number of triangles, and sum of all the angles in a triangle is 180 degree. So you have to multiply by 180 degree and you will get sum of all the angles of the polygon. In case the polygon is regular, means all the sides are same length, then you have to divide by n. This is how you get each interior angle of a regular polygon. So in case of hexagon, for example, this is hexagon. There are 6 sides, A, B, C, D, E, F. N is equal to 6. So sum of all the angles theta, sum of all the angles will be 6 minus 2 into 180 degree. is equal to 4 into 180 degree, we get 720 degree. But what will be the value of each interior angle? What is the value of each interior angle? For that you have to divide by n, means 6. So we get divide by 6, we get what? 120 degree. So if you want to find each interior angle of a regular polygon, you have to apply this formula. N minus 2 into 180 degree divided by n. This is the formula for each interior angle of a regular polygon. But in books, what I see, this is very funny, because they do not write like this, they write like this. They introduce 2 in that. So you write like 2n minus 4 into 90 degree upon n. What is the purpose of this? Why do you do like that? Because you can take 2 common. If you take 2 common, it becomes like this. This is a very simple form. But they write like this, 2n minus 4 multiplied by 90, then divided by n. That is the each interior angle of a regular polygon. And you have to find the exterior angle. If you have to find each exterior angle of a regular polygon, in that case the formula is very simple, just 360 divided by n. Means whatever is the number of sides, you have to divide by that. So in case of suppose pentagon, we have to find the exterior angle. Exterior angle is equal to 360 divided by, this is pentagon, so divided by 5 we get 72 degree. But in case of interior angle, you have to apply this formula. In case of exterior angle, you have to apply this formula. So 2 formulas you have to keep in mind. I'm going to explain again. Two formulas you have to keep in mind. Each interior angle of a regular polygon, that is n minus 2 into 180 degree divided by n, and exterior angle is equal to 360 degree divided by n. You see exterior, you see interior, and sum of all the angles is equal to n minus 2 into 180 degree. You can also write 2n minus 4 into 90 degree. This formula can be also written as 2n minus 4 into 90 degree divided by n. In books I see this formula, I don't see this formula, but this is very funny. Why do you do that? Because you can take 2 common and you can write in the simplest form.